In the absence of AI and robotics, we might actually be in serious trouble. The long-term vision is extraordinary. We're building systems that could one day unlock scientific breakthroughs, accelerate climate solutions, and maybe even help cure cancer. But here's the uncomfortable question. How can AI be disrupting the job market while simultaneously losing billions of dollars? Today, we're unpacking that contradiction. Because according to a recent study, when AI systems were directly compared to humans performing real paid jobs, they performed worse 96.25% of the time. Let that sink in. Give an AI 10 professional tasks, and statistically, it will underperform humans on at least 9 of them. And this wasn't based on artificial benchmarks or lab simulations, it was based on real freelance work. For years, AI has been tested on academic challenges, coding tests, math problems, structured prompts, but those environments don't reflect the messy, detailed, high-expectation nature of actual paid work. So researchers introduced something called the Remote Labor Index, or RLI. The idea was simple. Take real jobs that were already completed by freelancers on platforms like Upwork, give the exact same instructions and files to AI models, and compare the output. Same brief, same assets, same expectations. The jobs covered everything from video production and graphic design to CAD modeling, game development, architecture, audio editing, and data visualization. Each job paid around $630 on average. So how did the AI systems perform? The best-performing model achieved a success rate of just 3.75%. That means even the top AI failed more than 96% of the time when judged against professional human standards. Some models performed even worse, scoring close to 1% success. Even allowing for newer versions, the failure rate remains overwhelmingly high. Now, what does failure actually mean in this context? Failure doesn't mean nonsense output. It means the deliverable did not meet or exceed the quality of a human freelancer in a paid environment. And the failures fell into 4 main categories. First, unusable outputs, corrupt files, incorrect formats, deliverables that couldn't be opened or properly used. Second, incomplete work, missing assets, truncated videos, an 8-second clip when an 8-minute project was required. Third, quality problems. Even when tasks were technically finished, the results often failed to meet professional standards. And fourth, inconsistencies. Architectural renders that changed between views. Floor plans that didn't match provided sketches. In short, the AI often looked competent on the surface, but struggled under real-world scrutiny. Now, this doesn't mean AI is useless. Far from it. The study also showed that AI performed well in certain areas: writing, simple coding, report drafting, data retrieval, web scraping, logo concepts, and advertising copy. And that aligns with what we already see. AI is excellent as a drafting assistant. It accelerates workflows. It generates ideas quickly. It reduces friction in repetitive tasks. As a productivity tool, it's powerful. But that's very different from being a reliable replacement for skilled professionals. And that distinction matters, especially when hundreds of billions of dollars are flowing into the industry. Many CEOs report limited financial returns from AI investments so far. Some firms that rushed to replace workers are now reconsidering those decisions. And major companies boasting about AI-written code have experienced serious software reliability issues. The pattern is emerging. AI works best with human oversight. Without structured implementation and clear understanding of its limitations, performance often degrades. There's also a deeper technical issue. Large language models don't truly understand the world. They predict patterns. They generate plausible responses based on probabilities, train them on millions of chess games, and they can describe strategies fluently yet still make illegal moves. They mimic intelligence, they don't necessarily internalize rules. Researchers like Jan LeCun argue that scaling these systems, more data, more compute, won't automatically solve this limitation. We may need fundamentally new approaches, and historically this wouldn't be surprising. Since the 1950s, multiple generations of AI researchers have claimed they were close to human-level intelligence. They weren't. That doesn't mean AI won't transform society. It likely will. But transformation takes time, breakthroughs, new architectures, not just bigger funding rounds and louder marketing. And that brings us to the financial side. If current AI systems were as revolutionary as advertised, would companies need to spend hundreds of thousands of dollars paying influencers to promote them? There's a noticeable gap between hype and measurable capability. That doesn't signal collapse, but it does signal risk. Significant financial risk, especially if capital is allocated under the assumption that AI is ready to replace large portions of the workforce right now. As of early 2026, the picture looks more nuanced. AI is strong in narrow domains, impressive in language, helpful in coding, powerful as an assistant. But in generalized professional labor, where precision, consistency, and accountability matter, humans remain far ahead. So perhaps the real story isn't that AI is replacing us, it's that AI is becoming a co-pilot, a sophisticated tool. And like any tool, its value depends on how intelligently we use it. The future may absolutely belong to advanced AI and robotics, but today, we're not there yet.